the DC generator, parallel operation of DC generator is not studied. Will
No,
will that be important?
that I didn't discuss. That I will discuss later. And actually,
Okay,
all
sir.
this application part I haven't discussed. Okay, application of different types of DC generator. What type of DC generator is in which application, and what type of DC motors are used in which application, that I didn't discuss. So I would definitely discuss the applications for different type of DC machines later, and later stages of this class. Okay. So if you have any
স্যার বলছি
Okay, sir.
স্যার বলছি ওই সিরিজ ডিসি মোটরে ওই স্পিড টর্কের যে গ্রাফটা ছিল ওটাতে দুটো ছিল, একটাতে স্যার যখন আর্মেচার রিয়াকশনটাকে আমরা ধরছি না তখন একটা গ্রাফ দেখিয়েছিলেন যেটা ফার্স্টে হাইপারবোলিক, আর সেকেন্ড গ্রাফটা স্যার একটু বলবেন?
সেকেন্ড গ্রাফটাও হাইপারবোলিক, শুধু স্লোপটা কম হয়ে যাবে। সেকেন্ড হাফ
ওটা কি স্যার পরে
সেকেন্ড গ্রাফটাও হাইপারবোলিকই ছিল, শুধু তার স্লোপটা কমে যাবে। ওকে, সো দ্যাট ইজ দ্য ডিফারেন্স। Let me draw this one second, then I will. So let me start the recording. Okay, so recording has been
হ্যালো
started.
স্যার, আমার একটা ডাউট ছিল
হুম,
স্যার। ওই ডিসি মোটরের যে কোর লসের পার্টটা, ওটা এক্সপ্রেশনের কোন পার্টটাতে আমরা কনসিডার করি?
we haven't considered that, but we have to consider that. Okay, so let me first.
Last ক্লাসে you said that
বলো।
conduct a few experiments, but then ওই পার্টটা ক্লিয়ার হয় না কোন। So last ক্লাসে আপনি বলেছিলেন যে we conduct a few experiments to separate the losses, but মানে ওই পার্টটা এখনো পুরোটা ক্লিয়ার না যে।
So this curve I have drawn for the DC series motor speed torque characteristics. Series motor. And without armature reaction, the board line, and for very high torque, then it will the torque characteristics, speed torque characteristics will deviate from its ideal one due to the armature reaction, and the slope will reduce. So this is the difference without armature reaction and with armature reaction speed torque characteristics for DC series motor. Now the next question that we have, that where we should consider the core loss, isn't it? Is that the question? Okay, now if we want to consider the core loss, then what we have to do, this VTIL. Okay, so that is the actual input power. Okay, now this minus what you have done, this minus I square RA, this is the copper loss. So here we have to subtract the core loss. Okay, then the whatever the power is left, that is readily available to be converted to mechanical power. So these are the losses, two losses, one is electrical, another is magnetic, you can say. So this is the electrical loss and this is the magnetic loss. As a DC machine is basically an electromagnetic device also, so therefore we can expect one loss from electrical side, another loss from the magnetic side. Okay, so this is the input power. Input power, and this is the mechanical power developed. Okay, so is that clear? Is your doubt clear now?
Yes.
Now this, after generation of this torque and omega, you can say this is Te into omega r rather, because Te for electromagnetic torque and omega is the rotational angular speed. Now after this power, mechanical power, which is just developed, then we'll have some losses. These are all called mechanical losses. Okay, so these are called mechanical losses. And this W is for windage and B for bearing. Then actually we'll get the shaft power. This power will be available on the shaft where you will connect your load. So this is how the power flow occurs in a DC machine. Okay, now this windage is basically the friction with the wind. Okay, so this is the friction with air. As the machine is being rotated in a normal environment, not in vacuum or not at the surface of moon, so therefore we can expect some friction with air. So therefore the windage loss will come into consideration. Now another frictional losses comes from the bearing. Now the machine, the rotational system, when it is rotating, it has supports at both the ends. Okay, so this is called the bearing. So this is one bearing and this is another bearing. So these are two bearings in the machine. Okay, now due to the friction with this bearing and this shaft, we can get some bearing friction losses. Okay, now the bearing friction losses we can reduce by proper lubrication in the bearing, but still some sort of bearing losses will be there. We cannot avoid this. So these are the actual losses in any rotational machines. Okay, so is the point clear? Just see if you have any doubt. Okay, now if we have the question that how do we separate these losses during the experiment? So we separate the losses one by one. First, we run the machine at, uh, at which is having the all the conditions. That means which is having load current, which is having full voltage, okay, which is having full load. So everything is rated condition. Okay, so there we can get all these losses. Now what we do, we uh, reduce the losses one by one. First, what we do, uh, we reduce the electrical load. Okay, so if we reduce the electrical load, then this I square RA part will be reduced. Okay, then what we do, actually there is a machine, DC, two identical DC machines are connected. Okay, so two identical DC machines are connected by some coupling. One is one runs as a generator, another runs as a motor. Part of the losses we separate from this generator, part of the losses we separate from the motors. Okay, because it is not possible to separate all the losses from the same machine. So therefore, part of the losses we get from the generator and part of the losses we get from the motor. As we are using two exactly identical motors, so we can say that each motor has these losses, or each machine has these losses. Okay, any other doubt? Any more doubt? Okay. If you now let me ask you some question, because I told you that I will ask a question randomly. Okay. I will ask Bishal Bormon. Bishal Bormon, are you there? Okay. So Bishal, can you tell me that in DC shunt motor, what type of torque speed characteristics, sorry, torque current characteristics we get? Bishal Bormon.
Torque.
In case of DC shunt motor,
কি বলেছেন আগে বলেন?
in
Torque.
case of DC shunt motor, what type of torque current characteristics do we get?
Sir, it is linear, sir.
This
Linear, sir, linear.
when I will ask you to mute yourself, you mute. Otherwise, when I'm asking you, in between you don't mute yourself. Clear?
Okay, sir.
Okay. Now, why it is linear? Can you explain?
Yes, sir, because T equal to K phi, matlab Y equal to mx, sir. It is a
No, y
This
equals
kind
to
of
mx is
formula.
okay, but what is the torque relation? T equals to, again you are muting. Why?
K phi.
Is there any problem
No,
with
no,
your
sir.
device,
Sorry, sir.
or you don't
No, sir.
understand my language?
Sir, T equal to K phi IA.
Okay, so now you mute yourself.
Okay, sir.
Okay, now I will ask Abu Shahid Sheikh.
Yes, sir.
What is the power balance equation
Or
for DC machine, DC motors? পারবে? ছেড়ে দাও। Ion query?
Yes, sir.
What is power balance equation?
Hello, sir.
What is power
V
balance
equals
equation?
to EA plus I.
Hmm?
Power balance equation. একটা equation হচ্ছে say VT equals to EA plus IARA plus 2. একটা voltage equation.
You don't understand the unit of voltage and unit of power. So you are saying this VT equals to IARA plus EB.
না না সেটাতে আবার I multiply করে দেবো মানে power করে দেবো মানে VT IA equals to EA IA plus IA square RA plus 2 IA অমনি কিছু হবে
Mute
তো?
yourself. Binay Kumar Rajak,
Yes, sir.
tell me this power balance equation.
Sir, the thing which is just written on the board.
That is not the power balance equation exactly. The power balance equation which I told in the last class. Vipro Das, roll number 65.
Yes, sir. Yes, sir.
Can you tell me the power balance equation?
Sir, EA equals TEWR.
Okay, what is EA?
EA is a armature. Sir, T হচ্ছে ইলেকট্রোম্যাগনেটিক টর্ক আর WR হচ্ছে রোটেশনাল স্পিড অফ রেড পার সেকেন্ড আর I হচ্ছে আর্মেচার রিঅ্যাকশন অফ দ্য কারেন্ট আর E হচ্ছে স্যার স্যার এটা ঠিক বলতে পারবেন না।
Mute yourself. Oindrila Haldar,
Yes, sir.
tell me this.
Sir, can you please repeat the question?
Many
Yes.
times I am repeating the question. You are the fourth person.
Sir, I have to
Yes.
say EB into I is equal to T into omega R.
What is EB?
So the back EMF.
Why it is generated? How it is generated?
Sir, yes, sir. For the motor, sir, we supply the electrical. Sir, we basically supply VT, and when the arm rotor rotates, it generates an EMF. Sir, because the conductors cut the flux.
Just like in a generator, isn't it?
So that is the back. Yes, sir.
So for that you need some current flows through the armature. Or without current also it can produce that flux. So you
So
told
current flows through the armature.
that is required to produce EB. Suppose the current is not flowing to this armature. whether this EB will be generated. Okay, mute yourself.
Yes, sir.
Rukshanda Hussain,
Yes, sir.
can you answer this? That if there is no armature current, whether the back EMF will be generated?
Um, Sir, which motor are we considering?
Hmm?
Which motor are we considering? Is it a shunt type motor or a
Any
series type motor?
DC motor. Okay, let's shunt type.
Sir, in case of the shunt type motor, once we are providing VT, there would be there should be some back EMF. There should be some back EMF that should be opposing the terminal voltage, and um,
Why
because
and how this
also
back EMF is
the
getting generated? That is my
man
question. Whether that current through the armature is responsible
yeah,
for that. I'm asking that why and how this armature
sir,
EMF or back EMF is getting generated in a DC motor. As the earlier student told that due to this armature current, the back EMF is getting generated. Is it true? So that means back EMF is generated due to this armature current, or without armature current, it can be generated.
sir, uh, one second, sir. EB equals to Z psi. So, due to the residual flux, we have some residual flux in the ferromagnetic substance. So, the residual flux in turn generates a EA in the armature, and that in turn generates the field current, which again gives rise to increase in the flux, and that way a current flows through the armature, because of which the back EMF is generated, because EB is exactly same as the EA, which is ZA by A into P psi N.
So for that, voltage develop is not required. Voltage you are giving here. Okay, so for this you need only the
Yes,
field
sir.
current, only the field flux, and the speed. So these two things are required, not the armature current. As it is very clear from this expression of EB, is nothing but the EA. In motor we call it back EMF, and in generator the same thing, we call it induced EMF. Okay, in generator, in motor we call it back EMF. The thing is same. Either we can write ZA by A P phi N. So that means what we need? We need a flux and speed. Where the armature current? You don't need the armature current, only the flux and speed. If the speed is 0, but still flux is there will be no back EMF. If the speed is there is no flux, then there will be no back EMF. As in case of shunt motor, always you are giving the flux, because always the supply voltage is connected across the field. That means always you are having the full flux. Okay, so that means without the armature current also, you will get the back EMF generated. These are all constants, isn't it? And this same expression also you can write like this. So that means you need the flux and you need the speed. Okay, is that clear? So you should have a clear idea about this, because These are the very basic concepts of electrical machines. And similar expression you will get for all the rotating machines, not only for DC machines. Anything do you have in your mind regarding this? Okay. Now, if we compare,
Sir, here I have a question, sir.
Hmm.
If we don't supply in a motor, we have to supply the current for the through the armature winding from supply. That's why when current carrying armature conductors are placed in the magnetic field, the motor starts to rotate. So that's why the back EMF generates. So if there is no current through the armature, why the motor will start rotating?
okay. Now suppose suddenly
here-
when the motor is rotating with some load, suddenly the load becomes 0. So the armature current is proportional to the load, isn't it? So then also the back EMF will be there.
Yes, sir.
Back EMF is no way dependent on the armature current.
Oh,
Suppose the armature circuit is as broken, then suddenly the current will be 0. Armature current will be 0. But still there will be the back EMF. Okay, so back EMF is proportional to
okay,
the
sir.
speed and the flux. As soon as
Yes, sir.
you
Speed
have
and
the
flux.
flux and speed, so the back EMF will be there. At the very beginning, when the motor is just
Okay, sir.
about to start, the back EMF becomes 0. But when it gains a certain speed, then it gets a certain back EMF. Okay.
sir.
Now that armature current is required to
Okay, sir.
generate the torque, not the back EMF. So these two things you have to understand. So one expression is EB equals to Ka phi omega r. Okay, another is Te equals to same constant, same flux, but here you have current. So this
Armature
armature
current.
current is related to the torque, and this speed is related to the back EMF. Again, these two are basically coming from the same thing. This is the right hand rule, and this is the left hand rule that you have studied in your 8th standard classes. Okay, so that means if we provide some flux, if we provide some mechanical movement, then we will get a voltage generated. Okay, and all this will be in perpendicular direction to each other. Here also, if we provide the flux, if we provide the armature current, then you will get the torque generated, and due to that torque, there will be some mechanical movement. So that is given by the left hand. Is that clear? So therefore, when I was discussing the basics theory in fundamental electrical engineering, then only I discussed the left hand rule and right hand rule very clearly. Now from this expression, another question I can ask you, that if we apply, okay, suppose I have a DC shunt motor or DC series motor also. Suppose I have a DC series motor. So these are the terminals, supply terminals rather. Now with this supply polarity, the DC motor is rotating in this direction. Now what will happen if I change the polarity? Okay, so if I change the polarity, then what will happen?
The direction of rotation of the motor will change, মানে opposite হয়ে যাবে।
Opposite হয়ে যাবে। Why? Can you explain this?
ফার্স্ট অফ অল ফ্লো অফ কারেন্টটা, আচ্ছা প্রথমে এটা কি মানে পোলারিটিকে ফার্স্টে ইনিশিয়ালি যেটা ছিল সেটা রাখা হয়েছে তারপরে চেঞ্জ করা হয়েছে, না চেঞ্জটাই এট ফার্স্ট ইয়ে দেওয়া হয়েছে?
বুঝলাম না। আমার প্রশ্নটা কি ক্লিয়ার নয়?
মানে
I have
ফার্স্টে
taken some polarity in which it
না
is
না আমি বলছি
pointing
যে
in a clockwise direction. Now I have changed the polarity. Okay, so during the change, during this change, I may also switch off first, then I have changed the polarity. Then what will be the direction of rotation? That I am asking.
Sir, same direction.
এটা
Same
ব্রেকিং হবে,
direction. Same
সেম
direction.
ডাইরেকশন হবে না, ব্রেকিং হবে
কি হবে?
স্যার, মানে ব্রেকিং অফ ডিসি মোটর।
No, I have mentioned that during this reversal, I have switched off the machine.
Sir, same
যাই হোক, সেটাও
direction
না
হবে।
হলেও কোনো অসুবিধা নেই।
স্যার
অপোজিট ডাইরেকশন।
স্যার স্যার
Sir,
এটা যখন প্রথমে যখন প্লাস মাইনাস ছিল তখন একটা ডিরেকশনে আছে, যখন বন্ধ করলে তখন তো ওটা রোটেশনাল এনার্জিটা তখন মানে ওটা যে মোশন আছে ওটা তখন মানে লস, হিট লস হিসেবে বেরিয়ে যাবে, তারপর তো নেগেটিভ প্লাস করলে তখন আবার ব্রেকিং হিসেবে কাজ করবে না।
বুঝলাম না।
আমি
কেন
বলছি যে যখন
ব্রেকিংটা কেন
direction of-
হবে? Why do you breaking? Whether you are getting an opposing torque that you
Yes.
see.
মানে উল্টো ডিরেকশনে।
হ্যাঁ, উল্টো ডিরেকশনে কেন হচ্ছে? That I am asking you. Why it will try to rotate in the opposite direction?
Sir,
That is,
Same
most
direction.
of you
Same
has
direction
already
হবে।
convinced. Okay, so most of you have already convinced that without by changing this polarity, the motor has to rotate in the opposite direction. Whatever the formula is there, whatever the theory is there, whatever the left hand rule, right hand rule is there, I know from my childhood that if the supply polarity reverses, the motor rotates in the reverse direction, isn't it?
Sir, same direction হবে।
Now why it will be in the same direction then?
Sir, torque is here Ka into phi into Ia.
Yes.
Phi is proportional to armature current here. So we can
Yes.
write that torque is proportional to Ia square. So if the Ia is reversed, in that case also the torque direction will be same.
Okay. So if armature current, suppose previous case the armature current is this. So now the armature current is this. So we have to write this minus Ia. So whatever the polarity of Ia, so if we go for the square, so the torque polarity doesn't change, isn't it? If we have plus or minus,
Yes, sir.
doesn't make any change to the torque. Is that clear?
স্যার কিন্তু প্র্যাকটিক্যালি আমরা যখন মোটরে ইয়েটা চেঞ্জ করে দিই পোলারিটিটা, তখন তো কিন্তু উল্টো সাইডে ঘুরতে লেগেছে, মানে
কোন মোটর দেখেছো তোমরা উল্টো সাইডে
যেটা
ঘোরে?
যে কোনো মানে এই
যে কোনো মোটর?
কারখানাতে যে মোটরগুলো থাকে,
স্যার এনি ডিসি মোটর উল্টো দিকে ঘোরে, মানে টার্মিনাল চেঞ্জ।
হ্যাঁ যে কোনো ডিসি মোটর
সেটা
যদি
কি ডিসি
টার্মিনাল
মোটর
চেঞ্জ
দেখেছো
করে
কোনোদিন
উল্টো
সেটা?
side এ-
এটা ডিসি সিরিজ মোটর কি? That is, you are sure that that is the DC series motor? It
না,
rotates in the opposite direction? Huh?
ওটা ডিসি মানে সিরিজ মোটর কিনা সেটা জানি।
আচ্ছা, ঠিক আছে। Now the next question. Okay, so this I have discussed for series motor. Now what will happen the same for a shunt motor? if I ask you that what this will happen in case of a shunt motor, where you have supply here, okay. So suppose this is the polarity for which it was rotating in the clockwise direction. Now we have changed the polarity to this. Now what will be the change in direction of rotation? Okay, think first, then try to answer this. Don't assume anything.
Sir, it will stop.
No, I have stopped it, then I have changed the polarity.
Sir, then it will not. It will rotate first by very low speed, and then it will stop rotative because the cumulatively the flux will decrease.
You haven't got my question. When I have given this polarity plus minus by this shown by this black, so then it was rotating in the clockwise direction. Then I stopped the machine, and machine has stopped its rotation. Then I have changed the polarity. I am not asking any dynamic phenomena.
স্যার সেম ডাইরেকশনই থাকবে।
ইয়েস স্যার, সেম ডাইরেকশনই থাকবে।
So that means here also you are saying that it will be in the same direction. But here the expression
Yes, sir.
is
ফ্লাক্স এবং
ফ্লাক্স ইনটু আইএ।
okay. So
ফ্লাক্স
that
এবং
means
দুটোর ডিরেকশন
here this is
maximum change
IA,
হচ্ছে।
here this is phi, isn't it? So in the opposite polarity,
ইয়েস স্যার।
so it will be minus IA and it will be minus phi. So that means if it is minus phi minus IA, so that means again you will get the same thing, isn't it? So that means it will
Yes,
rotate
sir.
in the same direction. তাই না? তাহলে আমরা যা যা ভাবতাম আমাদের ছোট ছোট ওই গাড়ি চালানোর সময় যে পোলারিটি উল্টো দিকে ঘুরছে, তাহলে ব্যাপারটা ওই রকম নয় ঠিক, তাই না? তাহলে কার পোলারিটি চেঞ্জ করতে হবে সেটা ভাবতে হবে। So this also you can answer, you don't have to go by these theories, just you can use your left hand rule. Okay, now stretch your left hand rule and you try to okay, so when you are stretching the left hand rule, it shows your thumb shows a certain direction, isn't it? So that is suppose for a certain polarity of supply. Now if we have changed the polarity, then both your index finger and the middle finger will change its direction. Then you try to see in which direction your thumbs direct. Have you seen this?
স্যার
বলো।
স্যার বলছি মোটরের যদি ডিরেকশন আমি চেঞ্জ করতে যাই তাহলে কি করতে
বলছি
হবে?
আমি তোমাকে যেটা বললাম সেটা করে দেখো একবার। লেফট হ্যান্ড রুলটা
স্যার এটা আরেকবার বলুন, এই
হ্যাঁ,
লেফট হ্যান্ড রুলটা বুঝতে পারিনি।
লেফট হ্যান্ড রুলটা জানো তো?
হ্যাঁ স্যার।
আচ্ছা, তাহলে ইন্ডেক্স ফিঙ্গারটা হচ্ছে ফ্লাক্সের ডিরেকশন, মিডল ফিঙ্গারটা হচ্ছে কারেন্টের ডিরেকশন, and the thumb shows the direction of movement. Now when you are stretching your left hand, 3 fingers, then it shows a certain direction of thumb. Now for these two conditions, that I have shown with that supply polarity change, both the flux and current changes, direction of the current changes. That means you have to reverse the direction of index finger and middle finger. If you change these, then you just try to see the direction of your thumb, whether it changes with respect to the earlier.
No, sir, same direction.
Same direction it will change. So that means you don't have to go by this theorem K phi IA, which you have learned in this class. By the left hand rule also you can explain this. Okay. এবার তোমাদের মনে হচ্ছে যে then how I will rotate the okay, I will change the direction of rotation just by changing either
স্যার সেপারেটলি এর সাইকেল
armature.
ইউজ করলে
Okay, for this also, if we change either the flux field terminal or the armature terminal. Now, if you have the provision to change, that means if you have a 4-pole machines, that means 2 armature terminals and 2 field terminals are coming out from this machine, then by interchanging either field terminal or by interchanging the armature terminal, either or. If you change the both, again it will give the same direction. Either you have to change the armature terminal or you have to change the field terminals. So this is easier for separately excited motor because there already you have 4 terminals separate. Is that clear? How we can change the direction of rotation? Either we have to make minus phi or you have to make minus IA. Clear? Now I will ask the next question, that what will happen if we apply an alternating voltage instead of this DC in this series motor?
কিছুই হবে না, লাইনে ঘুরতে থাকবে, মানে ক্লকওয়াইজ ডিরেকশনে ঘুরতে থাকবে।
হ্যালো হ্যালো, হ্যাঁ ঠিক আছে, বলো। কিছুই হবে না মানেটা কি দাঁড়ায়? No, that means there will be no effect. The machine will rotate in the same direction, or what?
Sir, as the supply voltage value is changing, so speed will not be constant here.
স্যার সিরিজ হ্যালো
বলো।
হ্যালো, আপনার
হ্যাঁ,
কোয়েশ্চেনটা
বলো।
একবার বলবেন, আরেকবার বলবেন, শুনতে পাইনি।
My question is, instead of applying a DC voltage, if we apply an AC voltage, then what will happen?
স্যার সিরিজ মোটরটা চলবে, বাট এসি আবার শান্ট মোটরটা চলবে না।
সিরিজ মোটরটা চলবে বলতে? চলবে মানে কি রকম ভাবে চলবে?
কারণ সিরিজ মোটরটা রান করবে ওখানে, ওটা একটা সাইনোসয়েডাল মানে এনটা মানে ওটা যে ইলেকট্রোমোটিভ যে ফোর্সটা থাকছে মানে টর্কটা থাকছে, ওটা তখন তো আইএস স্কয়ারের সঙ্গে প্রপোর্শনাল। তাহলে আইএ তো এমনি সাইনোসয়েডাল কারেন্ট, কিন্তু এখানে আইএটা আইএস স্কয়ারটা মানে ওখানে তো আর নেগেটিভ পার্টটা থাকছে না, তাই ওটা নেট টাউইটা সবসময় পজিটিভ থাকবে, অ্যাভারেজ টাউইটা।
স্যার কিন্তু স্পিডটা তো কম হবে, কারণ সেই F1 F2 ইন্ডাকশনটা লাগে, ইন্ডাকশনের একটা
Sir, speed will no longer be constant because pole
induction
strength is continuously decreasing and increasing.
At what frequency? Suppose the frequency I have given 50 hertz. Okay. So can you visualize this 50 hertz by your eyes, naked eyes? Can you visualize this 50 hertz?
No, sir.
স্যার
No, sir.
স্যার
then how we can say that motor will reduce then increase, reduce
Sir,
and increase? Is it possible? Due to the inertia, it will rotate.
sir,
No, sir.
I think it will rotate with the average value of the sinusoidal voltage because 50 hertz is too high frequency for the
Not
mechanical
average value, that
system.
is the RMS value. Because it's square is there. So that means DC
Yes,
series
sir,
motor
RMS
will
value.
run in alternating supply as well. Because you see, already we have seen there is no effect of supply polarity reversal. So that means alternating voltage means basically a supply polarity reversal, isn't it? Okay. So with respect to, so at some point this is positive, this is negative, this is positive, this is negative. So supply polarity reversal. Again, if we write by this expression, then we can get this sine square omega t. So that also will give me a some finite positive value. So that means in the same direction, the machine will rotate, but the speed will be lesser than the speed at a equivalent DC voltage. That we can say. But this you will learn in details when you will learn this series motor. As the DC series motor can run in DC as well as in AC. So therefore it is also called an universal motor. Okay, because the DC series motor can run in alternating supply as well. But as we have seen that the performance will reduce in alternating supply. So therefore we need some compensation when we try to rotate the same machine in alternating supplies. So that machine is called a compensated series motor. In general, this type of motor is called either universal motor or simply series motor, as I have written. So it is a series motor. The series motor you can see application in mixer grinder, in drill machines, in most of the machine tools where we need very high speed. Okay. So the series motor is very popular. So I will discuss the application of series motor in details in later classes. Now, if I ask you the same question about the shunt motor, okay, if we apply some alternating voltage instead of a DC voltage for a DC shunt motor, then what will happen? Anybody can answer this?
So the torque produced by positive and negative cycle will cancel out each other. So it won't rotate.
Torque?
So the torque produced during the positive and negative cycle will cancel each other out. So it won't rotate.
Why do we cancel each other? Because again, alternating supply means nothing but a supply polarity reversal, isn't it? So in that sense, it should rotate.
Yes.
Because already you have told that it doesn't have any sensitivity with the supply polarity reversal. If we change the polarity, still the motor will rotate in the same direction. But when we are applying a alternating voltage, then what will happen? Okay, so I think you won't able to answer this. Anybody will try this?
স্যার নেট স্পিড 0 হবে,
কেন?
কারণ ওখানে সাইনোসয়েডাল ভোল্টেজ যখন অ্যাপ্লাই করছি তাহলে ওর সঙ্গে সেম মানে ওটা ফেজার ডায়াগ্রামে যদি দেখা যায় তাহলে সেম ডিরেকশনে আর্মেচার কারেন্ট এবং অ্যাপ্লাইড ভোল্টেজটা থাকছে, বাট ওর সঙ্গে 90 ডিগ্রি করে থাকছে আইএফটা। তাই এবার ওই দুটোর যদি প্রোডাক্ট করা যায় তাহলে মানে আইএ এবং ফাই মানে আইএফ, তাহলে ওদের অ্যাভারেজ ভ্যালুটা সবসময় 0 হবে টাইম পিরিয়ডে একটা।
কেন?
তাই নেট অ্যাভারেজ টাইটাও 0 হচ্ছে। তাই
না কেন 90 ডিগ্রি কেন হচ্ছে? 90 ডিগ্রি তো
কারণ
হয়
স্যার ওটা তো
জেনারেলি।
একটা ইন্ডাক্টরের মধ্যে দিয়ে যাচ্ছেন।
হ্যাঁ,
হ্যাঁ।
তাতে ইন জেনারেল 90 ডিগ্রি হয়।
তাহলে 90 ডিগ্রিটা ফেজ ডিফারেন্স হয়ে থাকছে। হ্যাঁ,
কেন
তাহলে
90
এবার
ডিগ্রি কেন হচ্ছে?
যেটা টাও ইলেকট্রিক্যাল, কারণ স্যার ওটা ইন্ডাক্টর পাস করছে
আগেরটা তো ইন্ডাক্টরের মধ্যে
ওখানে,
দিয়ে
যে
pass
যে ওই
করছে। আগেরটা তো ইন্ডাক্টরের মধ্যে দিয়ে পাস করছে। There also we have the field, here also we have the
না
field. Okay, now let me answer this. Now, as I have already discussed, the series field and shunt field is quite different. Now, series field, when we design a series field, the series field contains very less number of turns and the thickness of the wire is almost incomparable to the armature conductor gauge, isn't it? But in case of shunt machine, the number of turns is very high and the thickness of the conductor which is used to make this shunt field is very thin. So that means the shunt field offers very high resistance as well as it contains large number of turns, the effective inductance will be very high. Now, when we write a steady state equation for a DC shunt machine or DC series mode machine, we don't consider this inductance. But if we apply a sinusoidal voltage, then this current, when it will bifurcate into field current and armature current, so here the inductance, as the inductance is very high, so that means the field current lags behind the armature current almost by 90 degree. Okay, due to this high inductance of the shunt field. Remember, the series field has very low inductance. Okay, so here the shunt field has very high inductance, so therefore this field current will lag the IA by 90 degree. Okay, so that means we'll get the product as 0. So that means the torque will not oscillating torque. The torque will be 0. In case of sinusoidal voltage application in DC shunt motor, the torque will be 0 as the product of this field flux and the armature current will be 0. Is that point clear? So therefore, the shunt motor doesn't rotate in sinusoidal voltage, though it has no effect in supply polarity reversal. Okay. Is the point clear? Now I will present here a few difference or few comparison between the DC shunt motor and DC series motor. Now, as we have seen in a DC shunt motor, the field flux is constant. Because in case of motor, the field is directly connected across the supply voltage. So always the field gets the supply voltage, and if the supply voltage doesn't change, the flux doesn't change or flux remains constant. Okay, but in a DC series motor, the flux is proportional to the armature current. Okay, but before saturation. So this is exactly proportional. Curve will be a straight line before saturation only. Number 2, here the starting flux equals to the full load flux. Because always the flux remains constant, already I told you. But here the starting flux is kept very high. That is 1.5 times of the full load flux. Because we know that at full load it will be reduced. So therefore, by design, it is kept almost 150% of the full load flux. Okay. So this we can say due to saturation. Now here the starting torque, the starting current is kept almost equals to the twice of the full load current. Here also the thing is same. The starting current is kept twice the full load current. But if that is the case, then what about the starting torque? What about the starting torque? Now starting torque, for the torque you know the expression. What is the expression? Expression is Ka I into I. If we write it, then we will get 2 into TFL. Now if we write it here, the starting torque, again this Ka phi st into IST. Then as we have 1.5 into 2, so we'll get 3 into phi FL into IFL. That means 3 into TFL. So that means in series
Sir?
motor, bolo.
স্যার একটা কোশ্চেন ইন মি, সিরিজ মোটরের স্টার্টিং ফ্লাক্সটা 1.5 কেন বলেন? ওটা
স্টার্টিং ফ্লাক্সটাকে 1.5 করা হয় যাতে we know that at full load condition, generally the full load point is selected near about or beyond the knee point of the VH curve. That means well into the saturation. So to consider the saturation beforehand, we take this starting flux more than the full load flux, so that during this saturation it will be reduced to the full load flux.
ওকে ওকে।
মানে আমরা জানি যে স্যাচুরেশন হয়ে ওটা অলরেডি কমে যাবে, সেই জন্য আগে থেকে ওটাকে বাড়িয়ে রাখা হয়। ওকে, যাতে ফুল লোডে গেলে ওটা ফুল লোড টর্কটা দেয়, মানে আইএফএল আর ফাইএফএল টা পাওয়া যায়। Clear? Okay. Next, how much time we have? So just 1 hour only. Now, starting of DC shunt motor. Starting of DC shunt motor. Now, if we see that what maybe the problem in starting of DC shunt motor. So this is a DC shunt motor. These are the field terminals. These are the armature terminals. These are the supply terminals. And it rotates in this direction. Okay. Now this is the line current divided into armature current and field current. Okay. Now if we switch on, suppose the machine is rated for 110 volt. Now if I switch on directly at 110 volt, so what may happen to this machine? Now initially, what is the back EMF? Because back EMF has the expression of ZA by A P phi N. As N is 0, so at starting, the N is almost 0. So that means the back EMF will be 0. Okay. Now the full load current is generally designed with this expression Vt minus EB, Vt minus EB by Ra, isn't it? That means you know this expression that Vt equals to EB plus IaRa. So this expression that you already know for the DC shunt motor or any DC motor. Okay. Now at full load condition, you will get a sufficient amount of EB. Okay. So that means there the full load current will be its rated value. Now at the starting, if the back EMF becomes 0, then what will be the starting current? What will be the armature starting current? It will be Vt minus 0. As we have seen, EV becomes 0 at the starting. Vt minus 0 by Ra. So that means this starting current is much greater than the full load current. Okay, so much greater than the full load current. Now what will happen if the starting current is much greater than the full load current? Now one thing you can say that if the current is very high, then the armature circuit will burn out. Okay, so there is a possibility of that, but that current which will flow through the machine will be for very small time. Okay, now for very small time, if the current flows through the armature's coil may not burn out. It can withstand that current. It's an instantaneous current. It is not a steady current. If steady current, a very high value of current flows for a long time, then the armature circuit or armature coil may burn out. Otherwise, it may not burn out. But what other problems may arise due to this? Do you have any idea?
So torque is very high.
Okay, so 1 point I got. That means there will be a sudden acceleration torque. Okay, so that means point number 1, as Swarnadeep told, that there will be a quick acceleration. Okay. Because if the current is very high, flux is constant, current is instantaneously very high, that means the very high torque gives quick acceleration. Now, what will happen if there is a very quick acceleration? The bearing may damage the mechanical system, that is the bearing. So the bearing may damage. Okay, that is one problem. Another problem, okay, so due to this high armature current, so there can be a huge sparking at the commutator. Sparking at the commutator. What else? Okay, now suppose if this happens repeatedly, this type of high amount of current for small time, so there will be huge stress on the insulation of the armature. So that means it will create deterioration of armature insulation. Insulation due to heat. And the most important point is that it will create a problem for other devices which are connected at the same line. Because when there is a huge current, suppose the current was 0, then there is a huge current, then the current decay to 0, then it remains like this. Okay, so suppose this is the current value. So this is the starting current. And that is the full load current. Okay, so this is the starting current and that is the full load current. So if this starting current flows for very small time, so that means we can consider this as an impulse of current. Now what will happen with the impulse of this current? Now what will happen? We generally don't consider the impedances or resistances of the line. Okay, because all the devices are connected to the supply through some wire. And when we do some analysis, we don't consider the wire resistance, wire impedance. But every wire has a finite impedance. Okay, now when this huge current will flow through this line, due to this finite line impedance, there will be a voltage drop, sudden voltage drop in the line. Suppose if I draw this, suppose this is the steady state voltage of the line. So during this period, there will be a voltage drop in the line which is called the voltage dip. Voltage dip. Okay, so that you can consider as an under voltage impulse in the line. Okay, now this voltage dip in the line, that means all the devices which are connected in the same line will be affected by this voltage dip, isn't it? So all the devices which are connected in the same line will be affected. Is that point clear? Do you have any doubt? So this is the problem with the starting of a DC shunt motor direct online. So this type of starting, so that means suppose I have a 110 volt supply, okay, and what I am doing, I am connecting this 110 volt directly to this machine. So this type of starting is called the direct online starting, DOL, direct online starting of the machine. But due to this direct online starting of the machine, this type of problem may arise. So therefore, this is not recommended for DC shunt motor. Instead, which we recommend that to use a proper starter for a DC shunt motor. Now, what will be there in the starter? Now, suppose if so how I can reduce this problem? How can we can avoid this problem of starting? Do you have any suggestion? That means initial current becomes high.
রেজিস্ট্যান্স বেশি থাক, মানে যদি সাপ্লাই করি তারপর ধীরে ধীরে রেজিস্ট্যান্সটা কমিয়ে,
So that means
initially if the resistance can be made high, then current will be small.
okay, so that means one suggestion I got, that if we have very high resistance at the beginning, so that means if we have additional resistance, suppose IST, we know that initially the back EMF will be 0. But for that time, if we increase this resistance, additional resistance, which will be connected in series with the armature, and when we'll get the back EMF slowly rising, slowly developing back EMF, if we can reduce this resistance, then the problem may be avoided. So that is one suggestion. Is that point clear? Initially, I will connect some resistance in series with the armature so that this current can be reduced. The starting can be reduced at least near about this full load current. Okay, so that this IST can be near to the full load current, because full load current anyway the armature can withstand. There will be no harm. Okay, so if I can select the value of RS such that with the assumption of EB equals to 0, it gives that IST which is almost equals to the IFL, then the problem can be avoided. So that is one suggestion I got. Any more suggestion?
Sir, can we apply the instead of applying the full load terminal voltage initially, there is if we apply fraction of the full load terminal voltage initially and then correspondingly increases the terminal voltage.
Okay, so that means it is very
Can
clear
you do
from
that?
this. Now, what you can see from these expressions, only one expression you have, which is Vt by Ra. Now, what you can do, either you can increase this Ra to reduce this Ist, or you can reduce this Vt. As simple as that. So one suggestion he has already got, already given, that if we increase the resistance. Now, if we reduce the voltage, then that also another possibility. So that means somehow if we reduce the voltage at the beginning, don't give the full voltage at the starting. Suppose you give only 40 volt. Okay, then you apply 60 volt. Then you apply 80 volt. So step by step, if we increase, then also I can get rid of this problem. Just a minute. Hello. Okay. So have you understood? So if we gradually increase this voltage from a lower value to the rated value, then also the problem may be avoided. So these two are the suggestions. বলো।
স্যার বলছি কি একটা ইন্ডাক্টরও তো বসিয়ে দিতে পারি, ওটাতে লিনিয়ারলি 210 ভোল্ট ইনক্রিজ করবে, মানে মানে আগে 40 60 80 210 অমনি করে না দিয়ে একটা ইন্ডাক্টর বসিয়ে দিতে পারি একটা।
ইন্ডাক্টর দিয়ে কি হবে? তুমি তো ডিসি ভোল্টেজ দিচ্ছ। বলো কি বলতে চাইছো?
ও সরি সরি সরি, হবে না হবে না, সরি।
Okay, sir, voltage, that how to increase the voltage, we have different devices nowadays available. So these techniques are very new one, using a variable DC supply, which is called the chopper circuit, chopper based drive.
Sir,
And this technique is
Sir.
the older one, which is called the simple starter, resistive starter. Just a minute, I am coming. So resistive
sir.
starter, I am coming to you. So this resistive starter we'll discuss in the next class. বলো এবার কি বলছো?
Sir, can we connect a very small resistance in parallel with that field? I mean, sir, sir, can we use a small resistance as a shunt and place a switch there so that initially maximum amount of current will flow through it, and then we can disconnect it so that.
But you need to have this flux also, isn't it? Otherwise, how the volt EMF, how this back EMF will be developed? Because back EMF is not only proportional to the speed, back EMF is also proportional to the flux. If we shunt the field, then you will not get sufficient flux to develop the back EMF, isn't it? Got my point?
Yes, sir. Yes, sir. I get it. Yes, sir. Got it.
Okay. Any more doubt? So I think you have understood this. And in the next class, I will discuss the starter, resistive starter for DC shunt motor. Then we will go for the speed control of DC shunt motor. I think we need 4 to 5 more classes to complete this syllabus. So including today's class, what is the, how many classes we have till today?
Sir, 18.
So is this the 18th class?
Yes, sir.
Okay, so